Hey guys, welcome back from spring break. It is our last 9 weeks of the year. So, what we're going to do is continue on with our chemistry unit for this semester. We are going to pick back up and review a few things for bonding and continue on with that. So, if you remember back in last 9 weeks, we started talking about single bonding. We're going to review that and review a few of those terms that we got introduced to last 9 weeks. And then we're going to go on to talking about double bonds and triple bonds and how they can be used to make a compound or a molecule. So let's get started. So these will be our notes for today. If you notice, we have a topic. It's single, double, and triple bonding. We have an essential question. How and why do atoms use valence electrons to form molecules and compounds? So let's review a few terms before we continue going. So we got introduced to the word atoms. All right, if you remember back in last 9 weeks, I introduced y'all to the Bohr model. This is an atom of chlorine, a single atom of chlorine. You remember our neutrons and our protons. So our neutrons and protons are in the nucleus, and surrounding the nucleus are our electrons. Okay, so depending on which element we're talking about, the neutrons and the protons will change as well as the electrons. So for chlorine, we have 17 protons, which is a positive charge. We have 18 neutrons, which is a neutral charge or no charge whatsoever. And on the outside, we have 17 electrons for a neutral atom of chlorine. So that is the atom of chlorine. That's one atom. So let's go back here. And these are our notes. So what I'm going to try to do for the rest of the 9 weeks is have your vocabulary terms on the left-hand side, and we're going to fill this in with some quick, easy definitions for our terms. So again, our essential question is, how and why do atoms use valence electrons to form molecules and compounds? Our first term that we need to remember are atoms, which is the smallest particle of an atom or element that can exist alone or in combination So combination is basically when we are starting to get to understanding bonding. And remember, one atom contains neutrons, protons, and electrons are all in the atom. So an atom is the smallest particle of an element. What that means is it cannot be broken down any further. When you break an atom apart, you are now getting into a new area of chemistry. So an atom is just the smallest particle of an element that makes up that element. So example, if we do chlorine, this is the smallest part of a chlorine atom. If we break this down, start removing protons, removing neutrons, removing electrons, this is no longer chlorine. So the next term, if you remember, are valence electrons. So valence electrons So we've just done atom. Oh, can't see that color for anything. Let's go with pink. Hopefully it's good. We just did atoms. Now we're on to valence electrons. Okay. So valence electrons, let's go back to our little Bohr model, are the electrons that sit on that very outer shell. Okay. So I'm gonna get this nice pretty blue highlighter. So this is our outer shell for chlorine, and these are the electrons that sit on that outer ring. Those are our valence electrons. Okay, so let's go back and write our definition. So it's electrons located on the outermost energy shell. And they are responsible for bonding. And that leads us into our third term. So when we talk about bonding, just like if you have friends, y'all bond over certain likes, dislikes, favorite subjects, favorite books, things like that. We have atoms that like to bond together. So bonds are forces attracting valence electrons connect atoms together. So real quick, I'm going to let you get that down for a second, and then I'm going to show you something. Okay, if you haven't written it, you can go ahead and pause the video. So if we have our chlorine atom, we notice that, move this back a bit, that chlorine has this one lonely electron, right? If we had a second chlorine atom, that second chlorine atom that has one lonely valence electron as well can bond together. And those two electrons will connect and share a bond to make chlorine gas. So what I'm going to do is I'm going to draw the Lewis dot structure, because all we care about during bonding are those valence electrons. So chlorine has 7 valence electrons. I'm going to draw a second chlorine atom. Get right here in the frame. 7. Okay, so this one has 7 valence electrons. So when it bonds, when these two electrons bond, because you have this electron and that electron, these two are like, hey, dudes, I need you for a second. Let's bond together. I like you, you like me. Let's hold hands. And they will connect to make one bond. I'm going to keep this in the Lewis dot structure with all the dots resembling electrons for now. We're going to get to this where we're going to change these two electrons in the middle. We're going to change their structure just a tad bit. All right. So these two electrons connect to make a bond. So they start to bond. Okay. So that is what a bond is when two atoms merge together or connect through their valence electrons. Okay. Our next term is a molecule. I want to get molecule and compound very understood. They're very similar, but a little bit different. And I want to make sure you understand these two terms and the differences between these two terms. So a molecule is formed when two or more bond. So these can be the same elements, same atoms of elements. So like two hydrogens or two chlorines, they bond together to make I'm going to write this out, sorry, because you cannot see. So say if I have a hydrogen and it bonds with another hydrogen, those are two atoms. Two atoms of hydrogen bond together to make one molecule. You can also have, say, carbon and a hydrogen that bond. These are two different elements, two different atoms, but it still makes a molecule. All right. So no matter if it's two atoms, two or more atoms will make one molecule. A compound, okay, this is where the compound is a little different. A compound is composed of two or more atoms bonded. However, this is where it gets where it changes up. Okay, a compound. If you have two atoms, they have to be different. Okay. So we're at least two of those atoms are different. So up here, real quick. So if we're looking back at this would not be a compound. Two hydrogens is not a compound. It is a molecule because they are the same atom. However, if we go to C and H, we go to carbon and hydrogen, that is a compound because it's two different atoms. So I'm going to give you a couple of examples down here. So if we have carbon bonded to oxygen, make sure I have the correct electrons in here. Do not get confused with these dots. I'm just showing you a bond between carbon and oxygen right now. I'll explain these in just a minute. So if we have carbon bonded to two oxygens, okay, this is a compound because you have two elements, two different atoms right here. Even though these two oxygens are the same, you have a carbon that splits them. So you have a carbon in there, which is different than your oxygens, which makes this a compound. Another one is if you do oxygen and hydrogen. This is a compound because it is two different atoms. So again, two hydrogens bonded or two oxygens bonded is a molecule. So they're the same element atoms. But if you change it and you put a completely different one in there, so like you have carbon and oxygen, that is a compound. All right, let's move on. And now let's go to the fun part. I'm going to raise this up to bring it out a little bit. Now we're going to go back to the fun part, making bonds. I'm going to scooch this under so I can do there we go. All right, so now we're going to get to, I'm trying to, there we go. All right, now we're going to go on to making bonds, creating bonds. We're going to review single bond real quick because we did that last 9 weeks. So a single bond is formed there we go. Let's try this one. Single bonds formed when one pair of valence electrons is shared between atoms. Okay, let me fix that. So creating a single bond, you only use one pair of valence electrons. So if we go real quick, go back to our chlorine. This is one pair of valence electrons that they're going to start sharing together. Even though they only had one apiece, they connected it and made a pair. So now they're sharing that pair of electrons. So for an example, let's draw the little, we're going to go for examples. We're going to do sodium and chlorine bond together to make sodium chloride. So sodium, remember sodium has one valence electron and chlorine has 7 valence electrons. So altogether, they're going to have 8 surrounding. So chlorine has 1, 2, 3, 4, 5, 6, 7. All right. One thing that I didn't go over last 9 weeks, or I did, but I didn't really go into it a lot. We have a thing that a lot of our elements or atoms like to obey the octet rule. Okay. An octet rule is, so like chlorine is dying to have 8 valence electrons surrounding them. Sodium wants to get rid of this 1 valence electron because its innermost ring is completely full. They don't want to have any lonely electrons. So if we go back to chlorine real quick, our Bohr model of chlorine. Okay. We have this Bohr model of chlorine. It needs that 1 electron to come here to make it happy. If we take, I'm trying to get a, do this way. Nope, that's not going to work. If we had sodium, sodium is in group 1, period 2. It has 2 rings. So I'm just going to do Na. This is going to be my nucleus for sodium. So this is my nucleus. This is my first ring, second ring. Its first ring has those 2 electrons, and that second ring has that 1 lonely electron. This inner ring is stable. It is happy. It's content. It cannot get any more in there. This outer ring, though, is very unbalanced. It's not balanced because it has that 1 lonely electron. So if you can get rid of that electron or bond with something, that electron is going to be happy and it's going to be balanced. So that's what the octet rule is. All atoms want to be balanced. Okay, so let's go back to this real quick. So we have chlorine has 7, sodium has 1. So if we count these, we have 8 valence electrons that we can play with. So if we come over here on the side and write out sodium, and we write, I'm just going to stick with the same color, chlorine. Okay, so if we go 1, 2, 3, 4, 5, 6, okay, we know there's 6. We need 2 more to play with. Sodium has this one, chlorine has this one. This is where I was telling you earlier that I was going to change up the little bit of a design on our Lewis dot structure for a compound. All we're going to do we're going to start getting used to drawing a line instead of these 2 dots. Because like I keep saying in class, I'm efficient with my time. I'm not lazy. Drawing these dots, that takes a little too much. I could just go boom and be happy with it. Because if we look at this line represents 2 electrons on each side. Like a dumbbell. If you've ever seen a dumbbell, you have a big side, 2 sides that are bigger on each side, and then you have that middle bar that connects those 2 pieces together. And that's the same concept here. But we can start getting rid of these dots and making it look so cute without those little dots on there. So if we look, now we can count. We have 1, 2, 3, 4, 5, 6, 7, 8 electrons. Chlorine is happy. Sodium is now happy because that electron that it had now has a buddy. Okay. And like I said, this will represent 1 single bond. That's just like you and your friends or you and your boyfriend, girlfriend, or whatever, holding hands going down the hall. Y'all are now 1 unit. Y'all are bonded together. Let's do another example real quick. Let's go down to hydrogen. So if we have hydrogen and hydrogen bond to make hydrogen gas. So each one of them has 1 valence electron. So we have two valence electrons that we can play with and try to figure out how to bond these elements together. Hydrogen here, hydrogen here. I'm going to use a black one, draw a little line, and we see that these two have now bonded their electrons together. So now they're holding hands, they're friendly, they're connected. Oh, sorry. Okay. So one thing I want to reiterate this. I'm going to restate this. Please do not get confused by this line in the middle. That line in the middle is just those electrons connecting together and making a bond. That's like you and your friends. Here's your hand, here's your friend's hand. They connect and they have that lines connecting the bodies together. Okay. Let's move on. And we are going to hit double bonds. Double bonds start getting really fun because that's when you start seeing an actual molecular structure of how they change, because an atom is not in a straight parallel line. They start creating little designs. We're not going to get into that quite yet, but that starts introducing some of the fun parts of it. So let's go on to double bonds. If a single bond takes into account one pair of electrons, then we can think of a double bond is formed. Minus two, gosh darn, I hate those markers. Is formed when two pairs of valence electrons are shared between two atoms. Yeah, crud. Two atoms. There we go. So let's go down and we'll see this for a second. All right, let's play with oxygen. So if we have two oxygen atoms, they bond to make O2, the oxygen gas that we breathe in every day. So let's draw this out. We have oxygen. Oxygen has 6 valence electrons, because remember it is in group 6. So it has 6 valence electrons. This one, of course, would have 6 valence electrons. Please don't get, one other thing. I will at times go from clockwise, so left to right around an atom. Other times I'll go counterclockwise, going right to left. I'm doing that so it's easier for you to see of how I am connecting some of these atoms. Okay, so if you notice, each one of those oxygen atoms has 6 valence electrons. Take that glare away a little bit. All right, but each one of these has 2 lonely electrons, 2 very lonely valence electrons. So we can take these when guys at home, I know I didn't cover this with you, but right before we went to spring break, we played a game of Bohr model wars, a Bohr model game in class, and I was letting y'all know that electrons are able to move. Okay, let me go back to where is my chlorine atom real quick. So these electrons aren't just stationary right here; they constantly move around, and they can move to make it easier for themselves to bond. So this one electron that was here can move around and remanipulate this atom to be able to bond with another atom. They are not stationary. So these two valence electrons on our oxygens, they're not just glued to that one spot. We can manipulate them and move them around to be able to bond. So what we can do here, because we like them together, we don't like them all over the place, right? So we have this one can bond with this one, and this one bonds with this one. But that does not look too great, right? So we're going to make this look more pleasing and make it look a little bit more structurally sound. Remember that each one of these has 6 valence electrons. So we need a total of 12 surrounding our 2 oxygen atoms. So if we do this, we have 1 oxygen here, 1 oxygen here. Let's do our ones that are not bonded first. So we have 1, 2, 3, 4, 5, 6, 7, 8. That's 8 electrons. If we go 9, 10, 11, 12. Okay. Now both of these oxygens are happy. Because if we go, because remember, these are sharing. These are going back and forth, back and forth. It's playing tug of war. Okay. They're going back and forth between each oxygen atom. So it'll have 1, 2, 3, 4, 5, 6. Let's do it this way. 1, 2, 3, 4, 5, 6, 7, 8 that it's going to have around itself. This will also have 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 1, 2, 3, 4, 5, 6, 7, 8. That will also have 8. Okay? I want you to get used to these little lines. Please get used to these. Those are basically connecting those 2 electrons together. So one thing I want you to learn, or not learn, I'm sorry, get used to. And if you would see this here, you have these 2 sets around oxygen that aren't used. They're just hanging out, they're bonded, they're together. They don't need nobody else. They got their bud. So what we call these are lone pair of electrons. So lone pair of electrons are just pairs of valence electrons that are not shared or bonded to another atom. So this oxygen is like, yeah, dude, these are mine. You're not taking these. I'm keeping these. These are mine. Hands off. Same thing with this one. This oxygen atom says these electrons are mine. Don't touch them. They're cool. Same with this group. Lone pairs are just electrons that atom says you cannot have these. These are mine. They're fine. Leave them alone. Okay. Now that we've got double bonds out of the way, let's move on to triple bonds. triple bonds are even more fun because that means less atoms are bonded together and they just connect together a lot stronger. So if you were to look real quick, I'm going to discuss something with you for a second. I'm going to talk about strength of bonds for just 1 second. A single bond, it's strong, but they only have that one little tether. So that's like if you are pulling a car, right? Pulling a car between with another vehicle. So a truck is pulling another car. If you have one single piece of rope connecting those two vehicles, it's hard to break it, but it is easily broken. You can snap that one piece of rope really easily. But if you take it and you add a second piece of rope, that strength gets a little bit stronger. Okay, they're now sharing that force, so it's harder to break them apart. And when you get to triple bonds, those are the strongest bonds. Okay, because that is like you having 3 pieces of rope connected to a vehicle. It's going to be a lot more energy to break those bonds than it would be to either break a double bond or a single bond. Okay, so this is a very strong type of bond between 2 atoms. So if we added it, define it. Let's do this one. So a triple bond is formed when 3 pairs of valence electrons are shared between 2 atoms. Okay, so let's look at this real quick and see what this means. Let's go down here. If you have 2 nitrogen atoms, they bond to make nitrogen, or N2, which is nitrogen gas. So go nitrogen. Nitrogen is in group 5, so it has 5 valence electrons. Okay, let's draw the Lewis dot structure. So it's 1, 2, 4, 5. 1, 2, 3, 4, 5. All right, if these are the only 2 atoms that are present, they are going to connect to each other. They're going to move their electrons around to be able to bond. So we're going to have this electron. Says, come here, bud. Let's bond together. This one connects to this one. And this is where it's going to get a little messy on my paper. And this one is going to come over here and bond with that one. Okay. But we can clean this up to make it look a lot better. So if we take it here, nitrogen bonded, we have our lone pairs right here at the top. Those do not get touched. They're happy. They got their buddy. They don't need nobody else. So let's draw our lone pairs first. Okay. Remember, there's 5 valence electrons for each nitrogen. So we need 10 electrons surrounding these 2 atoms of nitrogen. So if we go 1, 2, 3, I just moved all 3 of these to one side. 1, 2, 3. Now we can see how these electrons are bonded together. And that makes a triple bond. Now let's count these electrons real quick. So for this nitrogen right here, okay, this nitrogen right here, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. He now has 8 electrons that's going to be going around him at some point, okay? Now the one on my right-hand side, the nitrogen on my right. I just did my left, now I'm doing my right. I can go 1, 2, 3, 4, 5, 6, 7, 8. He has 8. That's going to be surrounding him at one point or another. If we count all of our electrons now that surround both of these, we have 6 in the middle, 6, 7, 8, 9, 10. 10 electrons. We had 5 for him, 5 for the one on our left, 5 on our right, which equals 10 electrons total that we can play with. Let's go down and do one more. Let's go to carbon bonds with oxygen to make carbon monoxide. Okay, so carbon, he's going to have 4 valence electrons because he's in group 4. Oxygen has 6 valence electrons because he's in group 6. This one gets a little bit tricky, okay? Carbon monoxide is a little bit of a weirdo, but I'm going to show you how electrons are forever moving around. We did say that we don't touch these before bonding. There are circumstances like carbon monoxide where they can be moved around to help out with bonding, okay? What I want you to pay attention to is valence electrons. We have 10 that we can play with. So 10 electrons that are going to surround these atoms. Carbon has 4 lonely ones. Oxygen has 2. Okay. I know this one can go here and that one can go there. But he still has 2 that are not happy. He has 2 sets that are happy. But they create a triple bond. I'm going to show you how that works, okay? Like I said, these move around. So carbon and oxygen. Carbon is going to have 1, 2, 3. Oxygen will have 3. And they are going to be bonded. Okay, that's 6 electrons. But I still need 4 more. If I go 1, 2, because now he has 6, 7, 8. Oxygen, 6, 7, 8. They each have 8 electrons that they want to keep, or that's going to surround them at one point or another. And if we count all electrons together, we have 1, or let me start out here on the right-hand side of oxygen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have met our total electrons for that compound. So like I said, electrons are fluid. They move just like the blood in our body continuously moves. Electrons will be moved, and we can actually manipulate them to fit what we need at times. We will never go beyond 3, a triple bond. We never go beyond a triple bond. That's as far as we go. We have single bond, double bond, and triple bond. That's as far as we go. That is our strongest bond, is that triple bond. So now we're going to move on and combine single and double bonds. Okay? Remember, we have a carbon. Carbon has 4 valence electrons because it is in group 4. Sorry, I wrote that backwards. It's 4 valence electrons. We have 2 carbons, and we have bonded to 4 hydrogens. I did a goof on my paper, so I'm going to write those extra 2 hydrogens down here as 1 valence electron for each. And each carbon has 4. So if we look at this, we have a total of 4, 8, 9, 10, 11, 12 electrons for this compound. So when you bond 2 carbons, 4 hydrogens together, it makes the compound ethylene, which is actually a fuel source that we use. So we are going to see the structure of ethylene. So we have carbon, and we have hydrogens. Hydrogen here, hydrogen, hydrogen. 1, 2, 3, 4. Okay. Remember, hydrogen can only make 1 bond. If we bond all 4 of these hydrogens, to 1 carbon, this carbon is stuck out in the blue and he's not going to be used. We need to use him. So here's the thing. Carbons will bond together before it bonds with hydrogens. So we have the carbons now are bonded. And now we need to use these hydrogens. Use a different color. We can use this hydrogen. We'll bond with that electron for carbon. Bonds there. Let me use another color. There. One more. And I'm trying not to cross over to any other hydrogen bonds. And that one's bonded. So you can see that the carbons are connected by 2 pairs. So it makes a double bond. So carbon, carbon. Let's do here, here. They're connected to their electrons. So, and if you notice that each carbon has 2 hydrogens, so that's 4 electrons. If we do hydrogen here, and a hydrogen here, we have a hydrogen here. Where's that purple? And hydrogen there. So if you notice, we have a double bond in the middle and 4 single bonds on the outside of those carbons. Now let's look at our electrons real quick, okay? So we had 12 total that we can play with. Let's make sure we have all of our electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 electrons. Let's make sure everybody is happy. Okay. Hydrogen, we know his one ring can only hold 2 electrons. He has 2. He's connected to 2. He's happy. Same thing with this hydrogen. He's connected to 2. He's happy. This hydrogen, yep. And hydrogen, yep. Okay. All hydrogens are happy. Let's look at our carbon on the right-hand side. Okay. Look at our carbon on the right. If he's bonded to 2 hydrogens, he's going to share those 4 electrons. So that's 4. He's connected to the carbon on the left, and he's sharing those 4 electrons. Those are nice and happy because they're bouncing back and forth between all of them. So he has 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. That carbon is happy. Let's go to the carbon on our left. He's bonded to both hydrogens. He has those 2 that he's sharing with hydrogen. He has these 4 that he's sharing with the carbon on the right. So 1, 2, 3, 4, 5, 6, 7, 8. He's happy. Good to go. Let's go down and look at how we introduce and combine triple and single bonds to make a compound. So again, carbon has 4 valence electrons. Hydrogen has 1 valence electron. And when we combine 2 carbons and 2 hydrogens, acetylene is formed. This is also another fuel source. So carbon, 1, 2, 3, 4, 1, 2, 3, 4. And then we have our hydrogens, which is 1 and 1. Again, we have 2 carbons and 2 hydrogens. Hydrogens can only make 1 bond apiece. So if we go and bond this 1 hydrogen, I'm going to draw right through the word hydrogen real quick, and connect those 2 electrons, and we connect these 2 electrons. Each carbon has 3 electrons that we can manipulate and connect together. So let's see how we can do this. We can go, try to make sure it stays in frame. We can go 1, 2, 3, and connect each one of those electrons together. So remember, each of the rope is basically like a knot. That's those electrons that are connected. I'm going to start taking those away as we move through our the rest of the 9 weeks. So if we come over here and we bond and form acetylene, we can go carbon and carbon will form a triple bond, doop, 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 and then bonded to each hydrogen. Okay, remember he had 4, 8, 9, 10 electrons that we can play with. Let's make sure we have all of our electrons accounted for. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. Okay. Hydrogen's happy. He's connected to 2. This carbon on the right-hand side is connected to 8 electrons because he's bonded to 2 here, bonded to 6 here. Carbon on the left, same thing. He has 8 electrons surrounding him. And carbon shares 2 electrons. Everyone is happy. We've created a triple and single bond. So those are bonding, and that's how we can create single, double, and triple bonds. So again, let's go back through real quick. Single bond is just the sharing of one pair of electrons between two atoms. Double bond is sharing two pairs, so one pair, two pairs. Triple bond is sharing three pairs, one pair, two pairs, three pairs. And then we can make a huge compound. These can get larger and larger and larger as we go. These are just very simple ones. Double bonds and single bonds, triple bonds, single bonds. So, and that is it for today. You have, if you have not done your warm up for today, go and do that, as well as your summary that is below your notes. You will have an assignment that will be published later in the week, so look out for that. Until next time, see y'all later.